like this, it's obvious that we have HDMI and HDBaseT working together. You can see that we're still using HDMI signals because we have HDMI cables. However, in a system like this, where we have a source device that has an HDBaseT output going into a sync device with an HDBaseT input, you might think that HDMI is not being used. To understand more, let's look inside an HDMI device. Here we have an HDMI source device, a Blu-ray player, and a sync device, a flat panel TV. If we look inside the Blu-ray player, we can see there is a decoder reading the disc and taking out the video and audio data, which is then sent to the HDMI transmitter chip. This converts the raw video and audio data into an HDMI signal, which can then be sent over an HDMI cable. On the other end of this, the HDMI signal is sent to an HDMI receiver chip. This converts the signal back into raw video and audio data, which gets sent to the graphics processor and the digital to analog converter respectively. And then ultimately we get our image and sound out of the display. So let's look at the same thing when we're using a HDBaseT device. We still have our Blu-ray decoder sending the raw video and audio to an HDMI transmitter chip. This converts the signal into HDMI, and then this HDMI signal is sent to the HDBaseT transmitter chip, and that gets converted to an HDBaseT signal, which we can then send over our CAT cable and receive at the other end, and then we go through the HDBaseT to convert back to HDMI receiver chip, and that sends the video and audio to the same places. In the system, we still have HDMI signals being used, and really we can say that the HDBaseT chip is really doing a format conversion between HDMI and HDBaseT on the transmit side, and then on the receive side, it's going HDBaseT to HDMI. So this is the Valens VS100 series chip, which is the original HDBaseT, what we would call full HDBaseT. So that gives you the 100 meters and the 5-play. There's also a Valens VS070 chip, which is HDBaseT Lite. You can tell if a product's using HDBaseT Lite because you don't get the full 5-play, you don't get the embedded Ethernet, for example, and you also only get 70 meters transmission. So to recap, HDMI and HDBaseT aren't competing. In fact, HDBaseT wouldn't even exist without HDMI. So they're very much related to each other. One of the key benefits of HDBaseT is that it emulates perfectly HDMI. So from the point of view of the devices, as far as they're concerned, they're just connected with one long HDMI cable. They don't even notice that HDBaseT is being used. So the signal going through 100 meters of HDBaseT should be the same as if it was going through 5 meters of HDMI. There's no compression or loss of information. So when it was based on the HDMI 1.4 standard, so it supports many of the same features like audio, 3D, 4K, and basically has the same bandwidth limitation in terms of resolution. So UHD at 30 Hertz or at 60 Hertz, but using the 420 color space. So if we look at our basic handshaking, which we've covered previously, just remind ourselves, we have our power 5 volt and our hot plug events that lets the source and sync device know that they're connected up and they're ready to receive. Then we read the EDID. Then if there's HDCP being used, this is where the keys would be exchanged and the HDCP handshake happens. And then we start sending the TMDS lanes, the video and audio. So how does this happen over HDBaseT? Well, there's no dedicated wires for the DDC or TMDS like there is inside an HDMI cable. So the EDID is sent through to the DDC through the HDBaseT device. So we send the EDID as the over the DDC to the HDBaseT device. This then gets converted into HDBaseT packets, and it's transmitted over, and it's converted back and sent over to the Blu-ray. Then the audio and video are sent through the TMDS channels. Again, it gets converted to HDBaseT, sent as packets, and then converted back to the display. So all of this happens extremely quickly. So the devices behave just as if they're connected directly through a normal HDMI cable. So it's on the order of less than 1 microsecond. As we saw with HDMI 1.4, HDBaseT also extends with 100 megabit Ethernet. So in the past, you'd have to connect all of your devices. If you want them on the network, they need their own network connection. But when using HDBaseT, because we're sharing a network channel through the HDBaseT, we can remove a lot of the additional Ethernet and network connections, which is definitely a big help when you're working on an installation. If we take a look at this meeting room example where we have a laptop on the table, we need to get the signal up to the projector on the roof. We can use HDBaseT to send a video signal, but we can also use it to control the projector and send the control signals as well. So we can do it with Ethernet, and we would connect it up like this. So we've got the Ethernet and HDMI connection to the laptop, and then we've got an Ethernet and HDMI connection to the projector, and then in between the transmit and receivers, we just have that one HDBaseT link. We could also do the same thing, but with RS-232. So how is data sent over HDBaseT? Unlike DVI and HDMI, where we have the dedicated wire pairs for specific types of data, HDBaseT is using CADX cables where there are only 4 wire pairs. So there wouldn't be enough wire pairs to dedicate to specific channels. So it's a full duplex transmission over all 4 wire pairs, which means that we have data being sent over all wire pairs in both directions. So we have 2 links, the downstream link and the upstream link. The downstream link is sending video, audio, AV control, which is effectively our DDC channel. So, you know, the hot plug signals and the EDID and all that, Ethernet and IR, and the control signals as well. So it's using all 4 differential wire pairs, PAM modulation, which we'll cover soon. It's packet-based, sending 500 million symbols per second, which equates to an 8 gigabit net bandwidth. The upstream link is slower and more limited, but more or less very similar. So we're sending the AV control, Ethernet, RS-232, and IR. It's also using all 4 wire pairs, PAM modulation, packet-based, but the speed is a lot slower. So only 12.5 million symbols per second, equivalent to 150 megabit net bandwidth. So in the beginning, power over HDBaseT was not very well defined. Some of our early devices, we were using a basic 12-volt power setup. This allowed devices to be powered in both directions. However, after some time, POH standard was developed. It's very similar to PoE, is using 48 volts. But it has much like PoE, it has an expensive chip to negotiate sending the power. So with our 12-volt system, you could power the extenders either way. You could have the transmitter powering the receiver, or you could have the receiver powering the transmitter. But it was only using 12 volts, which wasn't enough to power some of the more complicated transmitters and other devices. So this is where the power over HDBaseT came in. So you can transmit more power, but it's not bidirectional because you need the negotiating chips To make it bidirectional, you'd have to have both sets of chips in the same device, and it would actually make it pretty expensive.